Hi, this is Jaydeep Sai, and the topic which I have selected for this TikTok video is a parallel processing tutorial. Just discuss the abstract of the topic. Parallel processing. Parallel processing is used to increase the computational speed of computer systems by performing multiple data processing operations simultaneously. For example, while an instruction is being executed in ALU, the next instruction can be read from the memory. The system can have two or more ALUs and be able to execute multiple instructions at the same time. In addition, two or more processing is also used to speed up computing processing capability and increases with parallel processing, and with it the cost of system increases, but technological development has reduced hardware costs to the point where parallel processing methods are economically possible. Parallel processing derives from multiple levels of complexity. It is distinguished between parallel and serial operations by the type of registers used at the lowest level. So, the parallel processing is used to increase the computational power of the computing systems. So, in the parallel processing, the multiple parallel processing operations are simultaneously performed. For example, for the instruction being executed. For the arithmetical logical unit, here in the arithmetical logical unit where we are using the ALU for calculating the mathematical related problems. So for if the first instruction of the ALU is executed, then the next instruction can be read through the memory. So while calculating the uh, arithmetic operations are performed by ALU, simultaneously next instruction can also be performed, such as reading the data from the memory. So this is the parallel processing of the task, and at the same time, not only one arithmetical logical unit is performed at a time, many arithmetical logical units can also be performed at the same time. This refers to the parallel processing where multiple tasks are performed simultaneously. In addition, two or more processing can also be used to speed up the computing processing. So, by using this parallel processing, we are getting the output of the mathematical calculations of the arithmetical logical unit in a very less time. Parallel processing derives from multiple levels of complexity. So, when the parallel processing is very implemented to its extent level, then the cost of the hardware also increases. So, by the advancement in the technologies, the cost of the hardware for the implementation of the parallel processing has been reduced. As a result, now the parallel processing has become not so cost as it was in the before, and it is distinguished between parallel and serial operations by the type of register using the lowest level. So there is another processing, that is the serial processing, where the operations are performed one after one in a sequence. In the sequence of serial operations, we are using the registers, and on the basis of the type of the registers, the operation is distinct as whether it is a serial processing or a parallel processing. Shift registers. Registers work on one bit at a time in serial fashion, while parallel registers work simultaneously with all bits of the word. At high levels of complexity, parallel processing derives from having a plurality of functional units that perform separate or similar operations simultaneously. By distributing data among several functional units, parallel processing is installed. As an example, arithmetic shift and logic operations can be divided into three units, and operations are transformed into a each unit under the supervision of control unit. Floating point operations. Floating point operations can be divided into three circuits operating in parallel. Logic shift, and increment operations are performed concurrently on different data. All units are independent of each other. Therefore, one number is shifted while another number is being incremented. Generally, a multifunctional organization is associated with a complex control unit to coordinate several components. This is about the floating point operation. Here we have adder, subtractor, integrity, multiply, logic unit, shift unit, increment, floating point, add, subtract, floating point, multiply, floating point, divide. And here these are all connected to the processor register, and these are connected to the memory. This is about the processor with multiple functional units. Parallel processing, systolic arrays. The parallel processing approach diverges from traditional von Neumann architecture. One such approach is concept of systolic processing unit using systolic arrays. A systolic array is a network of processors that arithmetically compute and pass data through the system. They derive their name from drawing an analogy to how blood rhythmically flows from a biological heart as the data flows from memory in rhythmic fashion, passing through an elements before it returns to memory. It is also an example of pipelining along with parallel computing. It was introduced in 1970 and was used in Intel to make CMU's IWRAP processor in 1990. In systolic array, there are large number of identical simple processors or processing elements (PEs) that are arranged in well-organized structures such as linear or two-dimensional array. Each processing element is connected with the other PEs and has limited private storage. Here, the memory is connected to PE and PE is connected to memory again. So, PE is nothing but processing element. These are the elements which are used for the parallel processing. And characteristics parallel computing. Many processes are carried out simultaneously as the array have a non-centralized structure. Parallel computing is implemented pipelinability. It means that the array can achieve high speed. It shows a linear rate pipelinability. Synchronous evaluation. The computation of data is timed by a global clock, and then the data is passed through the network. The global clock synchronizes the array and has fixed length clock cycles. Repeatability. Most of the arrays have repetition and interconnection of single type of PE in entire network. Spatial locality. The cells have a local communication interconnection. Temporal locality. One unit time delay is at least required for transmission of signals from one cell to another. Modularity and regularity. A systolic array consists of processing units that are modular and have homogeneous interconnections, and the computer network can extend indefinitely. Advantages of systolic array. High degree of parallelism. The arrays employ a high degree of parallelism and can sustain a very high throughput. Compact and efficiency. They are highly compact, robust, and efficient. Simple and regular data and control flow. Data and control flow are simple and regular. So the advantages of this systolic array are high degree of parallelism. Array employs a high degree of parallelism and can sustain a high throughput. So this systolic array can provide high degree of parallelism. This can provide the opportunity for the high amount of parallel computing and can sustain a very high throughput. At the time of the high throughput, this systolic array can also sustain and compact and efficient. They are highly compact and robust and efficient. So these systolic arrays are highly compact, robust, and efficient. And another advantage is simple and regular data and control flow. Data and control flow are simple and regular. So the flow of the data, such as the data and control flow. Control flow is the flow of the data based on the condition. So this control flow of the data is very simple and regular. These are the advantages of the systolic array. Disadvantages of systolic array. So let's discuss the disadvantages of the systolic array. Simplified and inflexible. They are highly specialized and inflexible regarding the problems they can solve. So they are highly specialized and inflexible. So these systolic array are inflexible regarding the problems they can solve, difficult to build. So these systolic arrays are difficult to build and expensive. These systolic arrays are very expensive to build and they are expensive in cost. Features of systolic array. Array of processing elements. A systolic array consists of a large number of identical processing elements that are arranged in regular grid. Each processing element is capable of performing a simple operation on its input and passing the result to its neighbors. Pipelining processing. Systolic array are designed to operate in a pipelined manner with data flowing through the array in sequential manner. This allows for high throughput and low latency each processing element can begin working on next piece of data as soon as it finishes its current task. Local communication between processing element in the systolic array is typically done using local connections, which reduces the amount of data that needs to be transmitted over long distance. This can help